Determine the angles at which voltage and current will have specified values. First, we're supposed to remember the formula of the sine wave. The formula is V equals voltage peak sine theta. In our case, voltage peak is given. This is my voltage peak. Instantaneous voltage is also given, which is 32 millivolts. I have to find theta. In order to find theta, I have to divide both sides equation by whatever is multiplied to sine. I have to divide by voltage peak. Voltage peak and voltage peak will cancel out. And I'm going to have instantaneous voltage over voltage peak equals sine theta. I'm going to rewrite this, and I'm going to have sine theta equals instantaneous voltage over voltage peak. Next, I have to move sine to the right side. Simply write theta equals inverse sine, and I have instantaneous voltage over voltage peak. Now I can plug in the values and calculate the angle. So I have inverse sine, and instantaneous voltage is equal 32 millivolts over 50 millivolts. Why 50? Because I have 50 times 10 to negative 3. 10 to negative 3, power of 10, is represented by milli. Just plug this into the calculator and you will obtain 39.79 degrees. This is my angle in degrees. But sometimes we have to express the angle in radians. So we're supposed to use the formula for radians. Remember, radians are equal pi over 180 degrees times degrees, where pi over 180 will stay times 39.79 degrees. This is going to be equal 0.694 radians. Okay, and this is my angle expressed in degrees. And if someone wants to get the angle expressed in radians, this is my solution in radians. This time we're supposed to find the angle for the current. Again, the general formula for the sine wave is I equals, in this case, I peak sine theta. I have to find angle theta. What I have to do first, I have to divide both sides equation by whatever is multiplied to sine. Divide both sides equation by I peak. I peak and I peak will cancel out, and you're going to have instantaneous current divided by I peak equals sine theta. I'm going to move my right side to the left and left to right, and I'm going to write sine theta is equal I over I peak. In order to find theta, I have to move my sine to the other side, and I'm going to have theta equals inverse sine and instantaneous current over I peak. Now I have formula for angle. I can plug in the values of my currents. Simply copy down sine inverse, and I have I, which is 6.3 microamps, divided by 8.5 microamps. This is equal, microamps and microamps will cancel out, and use the calculator, and you're supposed to get the answer 47.83 degrees. This is the angle expressed in degrees. Next, we're supposed to find the angle in radians. Remember, radians are equal pi over 180 degrees times degrees. Remember, it's always good to write the formulas first, because you are going to memorize the formulas, and in future, if you are going to review the material, you are going to know from where you got what. Or if you are going to let your notebook for someone else is going to be able to understand whatever was covered in class. So just make sure that you are going to write always formula first, and after that you are going to perform the calculations. So I'm going to have pi over 180 degrees times degrees, which is equal 47.83 degrees. If you are going to plug into this calculator, pi divided by 180 times 47.83, you're supposed to obtain 0.834 radians. And this is my angle in radians.